O vídeo a seguir não é indicado para quem é idiota e acredita na Terra plana.
Saudações siderais! Estamos começando mais uma edição de Conexão Sideral. E nesta semana houve a reunião da Sociedade Astronômica Brasileira. E esteve presente lá, além de boa parte da comunidade astronômica nacional, a pesquisadora Debra Fischer, que ela é da Universidade Yale, nos Estados Unidos, e é uma das maiores pesquisadoras do mundo na pesquisa de planetas fora do Sistema Solar. E ela veio apresentar um projeto fascinante, que é o projeto das 100 Terras. É um objetivo audacioso e eles construíram um novo instrumento para isso, que vai ser instalado num telescópio patrocinado pelo Discovery Channel e pertencente ao Observatório Lowell, no Arizona. E esse instrumento vai ter a capacidade de detectar planetas do tamanho da Terra, em órbitas mais ou menos do tamanho da órbita da Terra, ao redor de estrelas mais ou menos do tamanho do Sol. Ou seja, análogos quase perfeitos do nosso planeta serão encontrados, e ela tem o objetivo de encontrar 100 deles nos arredores, aí numa bolha, uma pequena bolha ao redor do Sistema Solar, com 100 anos-luz de distância, ou seja, só na vizinhança próxima mesmo do Sol, buscar 100 terras para que elas sejam futuros alvos de busca por evidências de vida. Então é um projeto extremamente interessante e a Debra Fischer é uma pesquisadora super consagrada. Ela foi responsável pela descoberta do primeiro sistema multiplanetário lá em 1999, quando eles estavam começando a descobrir exoplanetas. Ela ajudou a equipe do Geoff Marcy e do Paul Butler, que eram dois dos principais caçadores de planetas na época, a identificar o primeiro sistema com múltiplos planetas, e a gente vai conversar sobre isso na entrevista, sobre a evolução do campo aí nos últimos 20 anos, quando a gente saltou de ter nenhum planeta descoberto para ter milhares de planetas. E vamos falar das perspectivas desse novo instrumento e da ideia que está nascendo aí de instalar uma réplica desse instrumento no telescópio SOAR, que é um telescópio de participação brasileira, uma parceria entre brasileiros e americanos, que está instalado lá no Chile, e colocaria realmente o SOAR no primeiro time da busca por planetas similares à Terra fora do Sistema Solar. Se a gente fizesse essa réplica do instrumento, do espectrógrafo, que eles chamam de Express, essa réplica chamaria Sorceres e seria instalada no SOAR. Existem negociações aí em andamento, um custo mais ou menos de 5 milhões de dólares para fazer isso acontecer. Eles estão buscando financiamento e nós vamos conversar vamos conversar sobre isso também na entrevista com a Debra Fischer. Acompanha aí e claro, eu tive que ir até a USP, onde estava sendo realizado o encontro, para filmar a entrevista. O som não está muito legal porque tinha muito eco na sala e eu só tenho a imagem da Debra Fischer, não tenho a minha imagem fazendo a entrevista, sabe como é? A gente teve que improvisar ali na hora, mas ainda assim dá para entender direitinho, dá para seguir com as legendas tudo que está sendo dito. Então eu espero que vocês curtam, porque realmente é um projeto empolgante. Para quem curte a busca de planetas fora do Sistema Solar, e em particular a busca de planetas similares à Terra e a busca de vida, essa entrevista é imperdível. Acompanha aí.
Well, first of all, it's such an honor and a pleasure talking to you because, you know, as I said, I've been following this field for a long time. And first of all, I'd like you to introduce, I know you did that on the talk, but I'd like you to introduce the 100 Earths project.
Okay, sure. So the idea is that we have built a spectrograph. This has been 20 years of my career getting to this point. And we believe that the instrumental precision will be good enough so that we'll be able to detect real analogs of our own solar system. And this is something that hasn't been done before. So we found a lot of planets that are big with the Doppler technique, and we found with the transiting techniques a lot of planets that are in close, even the size of the Earth. But we haven't found planets that are like the Earth, that orbit at a distance from the star where liquid water is likely to pool on the surface. And of course, the reason that we're interested in these worlds is because they may be the places where life is most likely to evolve. We think the program's called 100 Earths because we think we need to have a large sample. It's unlikely that if you look at one Earth that you'll be lucky and find the one. But if the formation of life is ubiquitous, common, then by the time you look at 100 of these worlds, then, you know, hopefully some fraction of them will be likely places for life.
And what about range? You talk about a sample of 100 Earths, but from which distances from the solar system?
Right, so we are really looking at our closest neighbors. In this vast expanse of the Milky Way galaxy, we're looking at a tiny little volume of stars that are relatively close.
Can you give me a figure in terms of light years for
instance, sure.
stars?
I think most of the stars that we're looking at are closer than, for the highest precision, are closer than about 25 parsecs or closer than about 50 to 75 light years away.
I see. So less than 100 light years.
Less than 100
light
years.
Bubble.
Exactly. A little bubble. Yep.
Yeah. Cool. And I'd like to ask you to give us some perspective because you know, you've entered this field in a time where it was, you know, at least perilous for a scientist to go through with that.
That's right.
And I'd like you to tell us what motivated you to go into a field of looking for planets when nobody knew there would be any.
Right. Well, when I was finishing graduate school, the first planet had just been discovered by Michel Mayor and Didier Queloz. And in the United States, two astronomers, Paul Butler and Jeff Marcy, were starting to find the first few planets with their technique. So for me, it was just an incredibly lucky time to be at the right place and the right time when this field was just about to explode. But you're right. I remember the time before that when, you know, no one could get funding for the work, for the spectroscopic work, and you couldn't get telescope time either. Just a very small amount of telescope time. So all of those things really stood in the way of being able to make progress. But as soon as, you know, the first discoveries came through, then the field opened. In fact, a whole new field was created.
Yeah. But, you know, I was wondering if there was some apprehension because exoplanets had false starts before, right? People that said they had detected by astrometrics and
absolutely.
There was nothing there.
Yeah, and the time when I started, it was in 1997. And so the first few objects had been found, but even Michel Mayor and Didier Queloz and Jeff Marcy and Paul Butler were very careful about saying that these were planet candidates. There were no transits, there were no multi-planet systems that had been discovered. And so one could argue that since you're measuring the radial velocity technique, instead of seeing something edge on, you're looking nearly face on. And then the radial velocity signature would be very small, but it would still be a stellar binary system. So every talk that we gave in those days, we really had to justify why we thought this was a planet, you know, what other attributes we might see. And that all changed in 1999 when the first planet was observed to transit its host star. And that planet was detected with the radial velocity technique. So we could make a prediction of exactly what time at 7:30 tonight, plus or minus 30 minutes, we'll see the light from the star dim. And that was the 11th hot Jupiter that had been discovered. We expected 1 out of 10 to transit, and number 11 transited, confirming that the size of the object and the mass of the object meant that this really was a planet. And in 1999, the second thing that happened was that the first star with more than one planet was discovered. And since there were 3 planets orbiting the star, we knew that those couldn't be stars themselves. They dynamically, gravitationally would interact so that that wouldn't be possible. And so those 2 things that happened in 1999 changed the course. Before that, we were very, very cautious. After 1999, we became much more confident.
And on the other hand, you had the strangeness of it all, right? Because 51 Pegasi B is very strange.
Very strange, yeah.
And Epsilon Andromeda, which is the system you're mentioning, you helped to discover.
That's right.
It was full of giant planets very close to the star.
Exactly.
And how did the community deal with that? The realization that the solar system is not a good template for planet formation.
The community dealt with this the way that scientists always deal with it, with lots of arguments and discussion. And in fact, those characteristics that you just mentioned, the fact that the planet was so close to the star for 51 Peg, were part of the reasons that the other guys said, these can't be planets. They don't look like our solar system. We know that big gas giant planets like Jupiter orbit far away from their host stars because that's how it is in our solar system. So this was, not quite at the level of Copernicus, but like Copernicus was a real change in our understanding about how planets form and how they evolve. And I think it's taken all of 20 years to really try and put this into place.
And do you feel now we have a good grasp, because there's some discussion still about planetary migration versus in situ formation, and right now planetary migration is the favorite route for those planets, but is it set in stone?
Yeah, no, it's not set in stone. It's definitely, there is still a lot more to understand about these systems. As we bring new techniques to bear, direct imaging techniques, we're going to be able to get more information that will help us unravel this.
And as you said in your talk, I feel it's like we're having to bring every technique, every technology available to the table to make a more complete picture, right?
Exactly. And that's how it was, again, in 1999. We had this one technique that was finding what we now know are planets, but at the time we weren't confident, until we brought another technique, transit observations, to bear. And the two of them together were so much more powerful than just either one of those two techniques.
Now they're being implemented together, right? You preferably want to have transits and radial velocity.
That's the best, absolutely. To get the mass and to get the radius means you can calculate the density and really begin to understand what's going on with the planet.
Let's talk a little bit about Express, which is the instrument you've been working on, and it's going to harvest the 100 Earths.
Hope so, that's right, that's right.
You mentioned the need to go and do very precise measurements of radial velocities.
Right.
And you also mentioned the difficulty of filtering out the signal that comes from the stars.
That's right.
And it's basically noise for planetary searches.
That's right.
My question is, you're going to have the commissioning of the instrument now in November 2017.
Yeah.
This means you're up and running, or you have to still learn how to filter out those things to get to the precision you.
Yeah, that's a good question. So we've been working for 2 years. I work with a professor in statistics, and she and I, we mentor each other's students. We meet every single week, and still we are not at the point where we know exactly how, what techniques are going to be successful, but we are so much further down the road than we were when we started. So our first telescope time is scheduled in December of this year. We'll begin taking observations, and then we will use the techniques that we're developing now to see how well we can filter out this noise that comes from the surface of the star. I think, we all like to be optimistic and imagine that things will work right away. This is the third spectrograph that my team has built, so I'm a little more realistic. And I would say that, by next summer, we'll be in a very good position to know how well our statistical techniques are working and how precise the instrumental precision is.
And one thing that got me excited is the idea of bringing a replica to soar.
Right.
I was wondering what pieces are missing for this to happen, because it's very exciting to have.
Right.
SOAR is important in terms of Brazilian axis.
Absolutely.
I was very excited to hear it.
SOAR is such a beautiful telescope. And I've been working with a few of the Brazilian astronomers for about 2 years now on this idea of whether or not we could just replicate EXPRESS for SOAR. And there are a few small things we might want to change, to improvements we might want to make as we commission EXPRESS and learn what we should have done that would make it even a little better. But the reason that this makes a lot of sense is that there's a huge cost savings. We have all of the prints, right, to be able to build the instrument. So the design work is done. All of the code that we're developing for EXPRESS would just roll forward to Sorceress. So it means that, unlike EXPRESS, where we've had this long learning curve and we're still going to be working after the instrument is commissioned, I think with Sorceress you could imagine building the instrument in 18 months and within a few weeks you're up and running, not within months, several months.
I see. I hope this happens, because it's going to be cool.
It would be really cool. So the big thing is now whether or not we can find the funding to make this happen.
I see. Well, let's hope you find it.
That's right.
and I'd like to ask you a little bit about red dwarfs, because it's not the focus of your instrument. You're looking at G, K stars, but red dwarfs seem to be the next big thing,
right? I mean, look at Proxima Centauri and the TRAPPIST-1 system. These are all very red stars. So it turns out that we made a very late decision on EXPRESS. Originally, we planned to go just in the optical band, and at the almost 6 months or 9 months ago, we realized that if we changed some of the codings, that we could go out to almost 1 micron, so the near infrared. So that's what we're doing with EXPRESS, and with Sorceress, it's one of the things I would like to modify is to get bigger prisms so that the spectral orders in the red are more well separated. But it means that we can actually do the M dwarfs as well. And we've added to the EXPRESS project about a dozen very bright early type M dwarfs, because as you say, the Kepler statistics show that there are 25% of those stars have transiting rocky planets.
And there's some division among astronomers as well in terms of habitability.
Right, yeah.
Where do you stand on this?
My position is that we know so little that it is too arrogant to imagine that one system is not hospitable for life. What we need to do is just go out like scientists do and collect as much data as possible and then begin to sort through the data. There will be telescopes coming along in the next 20 years, like the LUVOIR telescope, the Large Ultraviolet Optical Infrared Telescope, 20-meter telescope out in space that will be able to look at the atmospheres of the planets and figure out if they're alive. So our job right now is to find those planets so that when we point the telescope, we know where to look and we know when to look.
One thing that I find incredible is that the public is getting excited right now because of James Webb.
Yeah.
And you're talking about LUVOIR in the 2030s.
That's right, exactly.
You're some steps ahead, right?
I'm just leading a community to investigate, both U.S. astronomers and international astronomers, to think about what we want to do in the future, because these missions take 20 years to plan. So you have to start thinking about this now.
Yeah, true.
Yeah.
And this comes into play when you talk about characterization of exoplanets, which is the next big frontier, right? We've been discovering them for 20 years or so, and now we want to know how they really are.
That's right, exactly. We want to get spectra and see if there's oxygen and methane and other chemical constituents that might signal life.
And what is the great jewel of the crown in this sense? Is it LUVOIR? what is going to do that for us really in a big way?
I think for measuring atmospheres, yes, it's a LUVOIR type mission. It's a space mission beyond James Webb, actually. So that's what we're all working towards. But then as we go, right, we learn new things which improve our ability to design the next step.
And LUVOIR at this point is in a competition, right? NASA has
decided.
Exactly.
It's I don't know if it's a competition. So NASA has set up 4 community study groups for 4 mission concepts. LUVOIR is the mission that I'm a community co-chair for. There's also HabX, which is a scaled down version of LUVOIR. It could also look at exoplanet atmospheres, but a much smaller number of them. And then there's a far infrared surveyor and an X-ray telescope. So the community is doing the work now to study and see which telescope gives the scientific community the biggest return on our investment. It takes a while to sort that out.
And looking from afar, do you feel the last 20 years were fast-paced, or were they not fast enough for you?
Yeah, no. The last 20 years has been an absolute explosion in this field of exoplanets, which went from 0 to now thousands. So it's been absolutely incredible.
Yeah, and some astronomers say we're maybe 1 decade or 2 decades of finding out whether we are alone or not in the universe.
Yeah.
How does it feel to be a part of that?
No, I think that's absolutely true. So that's probably beyond my career in 2 decades, but we're going to get there. Yeah.
Yeah, amazing. I thank you very much for your attention, Debra.
Thank you. Thanks, Salvador. Yeah.
Bom, essa foi a entrevista com a Debra Fischer, realmente muito simpática, muito solícita, sentou para conversar com a gente depois da palestra dela. Vocês viram que eu me refiro à palestra porque eu estava lá assistindo a palestra e depois fiz a entrevista com ela, com a ajuda do pessoal da assessoria da Sociedade Astronômica Brasileira, a quem agradecemos aqui neste vídeo. E este foi o Conexão Sideral de hoje, mas voltaremos em breve com mais entrevistas para você. Até lá!